So all right. So as a security architect, when I do my threat modeling, so the first thing I look at is the assets that I need to protect, right? And then I focus on the attack surfaces, the adversaries, the threats, and the mitigation, right? But today, I'm not going to talk about threat modeling, but instead, we'll look at what are the assets, like high value assets that we need to protect for an AI application. And then we will look into a comprehensive software framework which has tools and runtimes that are used for in-use protection, ownership, and data privacy across multiple domains. So this is an obligatory, Intel legal disclaimer. So with that out of our way, so in case of AI applications, so there are, what I see is there are two main assets that we need to protect, right? Apart from other assets like the analytics code and the secrets and actually the infrastructure, the two high value assets that I think about is the AI model itself and the data, right? Given your expertise and the content of this slide, I think I'll be preaching to the choir if I talk in detail about all these. But, as we all know, the AI development of the AI application is very costly and time intensive, right? And also the post-deployment control is very limited. That is, like, once a developer has deployed the model, it is very hard to control how it gets used and where it gets used. And similarly, as we understand, the data is of very high value and sensitive in nature. And also there are a lot of regulations, compliance that we need to take care of, right? So to address all these, problems, our team at Intel has developed and continues to develop, techniques and, solutions to protect these AI models and the data, at all life cycle of these assets. So let's look at the asset protection framework, also known as OpenVINO security add-on. Right? This is the set of tools and components designed to help safeguard the AI models throughout their life cycle, as in when they are at rest, in transit, and when they are in use. Similar protection is also extended to the data, be it the data that is input to the model or the data that is produced from the model. So the same protection is applied at all stages of the data, that is when it is stored or when it is transmitted or when it is being processed. And this framework also introduced the concept of ownership for the data, the AI model, and the data also. So, the protective solutions use Intel, platform security technologies like Intel SGX, virtualization technologies. So, let's go through, the process, process of how we protect the AI model first to begin with, right? So, on a side note, I've designed this slide to make sure that we are all alert, after this long day. So, if that is not working, let me know. I can, make it flash, so that I think we are all alert. So, this the following diagram illustrates two components in it, right? The one is at the top, the model development flow, and at the bottom we see the AI application flow, right? So as I said, this is a set of tools and components. So we have colored it so that you see the components, the tools that are used in the development process are the tools that you can use to protect the model, like encrypt it, and then add policies to it, and then share it with the model developers. And so what we do is we add, to start with, right? So we add a policy, control policies to the model to manage its usage. First thing is that, and then we protect the model. So once the model is protected using encryption, so it is shared with the application developers who will use the model, right? So the model usage policies also include the time period. Like say, if you purchase the license for a model and it is only valid for 30 days, so it makes sure that after 30 days, that model cannot be used. And the same if there is a count, right? So you buy it for 30 days, but you can only execute it for 100 times, right? So even that level of checking is also possible, right? So during the execution, the runtime actually, the model undergoes the usage checks, right? So once the usage check passes, then the model is allowed to use it. So to ensure in-use protection, we use Intel security, platform security technologies like Intel SGX and virtualization technology. Sorry. So we also need to ensure that the runtime software that is being run is what it is, and then the system is in a good known state, right? So to ensure in-use protection, we use the Intel SGX technologies to create trusted execution environment, and to ensure the runtime is the one that we are supposed to be running in. And also, we use the remote attestation, right? So through measured boot. So to enforce the policies, So to enforce the policies, we have established something called entitlement services. That's the blue box, not the purple box at the top. So which ensures, which checks the entitlement that the user is allowed. These entitlement service can be actually deployed by the model developer itself, or it can be through a trusted third party, right? And also you can add in the system attestation using providers like Intel Amber services to attest the system. So that was about the model protection. So similarly, even the data needs to be protected. So we can extend these usage checks and then the protection for the data as well. So just before the data is being processed by the AI application, it goes the same usage checks, and when the usage the check passes, the data can be processed. So even the output can go through the same process. So importantly, right, the owner of the data, the input data, might not be the owner of the output data. So you can also protect the output data in a similar way that we protected the input data. So the final outcome is production of high-value assets, data assets, and the system owner has control over how this data is being used. So now this is okay. Yeah, so the output data, right, that can also be protected in a similar way. Like even all of it, like the input data, the model, and then everything can run within the enclave. So I mean, it's a choice, right? If you want to protect only the model, then you can run the model within the TEE, but otherwise you can add all of it. So there is one concept where you can add ethical AI also, where you can have a composite licensing, where only one a particular model can be used by a particular application, or a particular data can be used by only a particular model. Say for example, there is a city street view video, right, as an input data. So you can restrict that to be used by an application which processes just the counting of the vehicles, right, but not the license plate, right? So you can have all combinations of that. So I have this is about a very high level view. Because of the lack of time, I couldn't go in all the details. So as I said, this is a set of tools where you have tools that can do encryption of the, it generates the required key, it encrypts the model, and then it creates a policy, and the policies are then shared with the developers and the entitlement services, right? So this is just a set of tools, not the whole workflow. So I would like to give a live demo of this. So where I have hosted this demo on Intel Developer Cloud Edge, right? Intel Developer Cloud Edge is where developers can prototype their inferencing application, and then do the performance benchmarking in real time on cloud, and across all multiple many multiple Intel platforms. So let me switch to the demo part. Okay. So this is the typical setup of these tool set, where you have on the left-hand side the developer, model developer side, where you develop the model, you encrypt it, and then you create policies. And also at the bottom of that, you see the licensing server. So in this case, the license server is hosted by the developer. On the right-hand side is the application flow, where the model that has been encrypted and protected is being served within a TEE, like Intel SGX, using Gramine. So and then the application on the top, the yellow box, will securely connect to that, use the model. So what I'm doing here is I have combined all those things in one system, so that it is demoable. So here I have a couple of steps, right? So the first step here I do is I provide the model input, and where the model files, and then the input data here. And the next step is set up some parameters that is required for doing all this process. And then I share the in the configuration file. This is the part where the configuration file is shared from the developer to the application user, right? So when I run through all these steps, and this is the actual part of the code where it actually runs all these, right? So I have the script here, where, as you can see, it can create the encryption key, and then it is creating this is the part where it encrypts the model and the key generation. And here you see it is creating the 30-day license that is required, and then starts the model server, and then loads up the model within the TE. So because it takes like two to 3 minutes, I'll not be running the actual thing, but the next step would be to run the actual, now the licensing server is up, and then you have the model served up. So I run the inferencing application using this one, and this is the input, the output video, right? As you can see here, the inferencing has been done, and then the object detection has happened. As you can see, there will be bounding boxes around the objects that were detected. And here's the logs of all the things that has happened. As you can see, the keys were created, and all the licensing and all that was happened here. And to conclude, so to conclude, here's this is a set of tools where you can use to safeguard the AI model, and even generic workload, and then the data. So, and it also adds the capability of model ownership and data ownership, and it is built for non-security expert, and it abstracts the security part of it, and easy to use. And it is open source project. It is on the GitHub. Please check it out, and also try out the Intel Developer Cloud Edge at no cost. Great, thank you.
Great, thank you. We have time for one question.
I'm curious about some of the sort of enforcement mechanisms that are bells and whistles that are available when you encrypt a model, which is, you said you could have a licensing for X number of days, or it could be running for X number of times, or are there any others?
Like again, I said, so encryption is different part, right? So you manage the keys, like, the users will give their public key, you encrypt it, but that's how the protection part is. But when it comes to policies, these are the policies, but you could add more policies if needed. It's all customizable, and you can add more policies, like if you can think of any.
All right, thank you.
Okay, let's thank our speaker one more time. Thank you.